Hello guys, and welcome to Redona Designs. I'm your host Riddick Okwemba, and this is our third video. If you've not watched the two previous videos, I implore you to go and watch them. I'll also leave a link in the description below. So just as a recap, in the last two videos we covered a step-by-step method of how you can come to design this parametric sheet metal enclosure using various methods, where we covered very many things in that video. So sorry, if you haven't watched that video, just go back and watch it. And then in the second video, we extracted the manufacturable parts, that is the flat patterns. And now in this video, I'm going to show you how to now communicate this information to the manufacturer so that they know how they can bend our part. So I'm going to go to file, and then we're going to make a drawing from the part. So we're going to go down and select the appropriate sheet. So I just happen to have my sheet format here of Redona Designs. I think in the next chapters we're going to capture how we can make our own drawing sheets. So over here we have several things. So first of all, we want to communicate how the part will look like, and then thereafter we can isolate the several parts and make a drawing of each of the sheet pattern, the flat pattern. So we can bring that view over there. This is the isometric view, so that we can have a look at how the final thing will look like. We can still go back to the drawing, and then we can have our front view, drag it right there, and then drag our side view right there. I think the scale and these two views are communicating enough, in addition to our 3D view over there. So we go to the annotation, select the smart dimension, and you can have our overall dimensions first of the part. So 72 millimeters, and this other one we can take it from there. Having difficulties in selecting this. So basically that's the length. The appropriate one is from there to there, so 180. And then we can say, let's have the height like so. So we have fully defined that final assembly. This is how it will look like. So let's go ahead and add another sheet, and then if you have a multi-body part in your sheet metal design, you can go through this dialog box. So it's going to highlight, we select our sheet metal part, we move on to the next button, and then over here we can actually select bodies. So what SolidWorks is going to do is going to bring you back to the body that you had designed, and we can start with our top cover. So you select it, click on OK, and over here we actually want it to not as the default, but okay, we need its flat pattern. We select its flat pattern, and then we click on OK. So for the most part, this contains all the information that you need. So you'll find that most laser cutters, either they're going to mark or score this line before now cutting, going over and cutting the whole geometry. So this is our cover. So we can name it, go to the annotations and give it a name. It's not responding. Anyway, so go back to annotation and give it a name. And we can call this one cover, maybe in caps, cover. Okay, so this information tells the one at the bending break how they're going to bend it and which direction. So we also need to give it an isometric view, or at least a 3D view, so that the person who is bending it can know, like, okay, this is how this thing is going to look like in the end. So we're going to take that view, click on OK, and we're going to place it over here. So that's enough. We're going to go to our next view and select our other body. We're going to select body again. Now this time around we're going to go to the base and then click on OK. So we still want to start with our flat pattern. Put it right there. And then I think for this one we can adjust the scale. So probably we can change the scale to 1 to 1.5, thereabouts, so that at least the wordings can be a bit legible. So that's okay. And then we can also get the isometric view. So same procedure, select the file, select the bodies, and then we're going to take the base, and this time around we're going to use its isometric view. Place it right there. Click on OK. I can try and adjust these views so that they fit. So if you want, you can dimension everything, but I find that when you dimension this part, it's more or less it's going to look very crowded given the bend information and everything. So you can select another sheet and maybe just give all the dimensions, but given that this is a DXF part, they're most likely going to give you score these lines one way or another. Or the other alternative is just have the overall dimension, so that at least sometimes DXFs have a tendency to, you know, go haywire, and you might find that one DXF has different dimensions when you take it to another software. So that's something to take note of. So probably just give it the overall dimensions, maybe from, let me just show you. So you can have a smart dimension maybe from here to here, so they can use to scale back this DXF should it ever need the scaling back. So I think that's that. Probably let's just denote this one as this is the base. And this is a quick one, so just you can take your time and do all that you need to make this, to communicate as much information as you want. But for the person or the people that I'm manufacturing with, this is enough information for me to give them. and for them to give me a doable or a workable file. So since we have done this for this base, maybe we can also do an overall measurement for the cover, like so. From there to there, the width, can have it like so. So yeah, so over here we can delete this cover, maybe give it another annotation right there, call it cover, and that's it. So yeah, so with that we can save this file, and because you don't know whether our vendor or the person we're going to manufacture with is going to be having SolidWorks, we can also save this part as a PDF file. So I think we come to the end of the video, and up to here everything is okay. You can go, you can manufacture your part. Remember, you can modify it however you feel like, because it's parametric. You can input all your dimensions and everything, so it's quite a resilient file, and you can do whatever you want with it. And as a bonus, I'm going to give you the next video, the last video, where I'm going to show you how we can automate this process into something that will be quite beautiful, and it's going to help us in the efficiency. So if you've been with me up to this point, thank you for your time, and I hope you've learned something. You can share the good news, tell a friend to tell a friend, and support our channel. You can like, comment, and I'll see you in the next videos. Thank you and cheers.